Welcome back. I am Bill Westlake, and this is Lag Demon Programming, and thanks for watching. In the last video, we took a look at values, references, and pointers, and in this video, we're going to use those concepts along with some data structures and start understanding how to put together some very simple algorithms. And we're going to do that in the context of a very simple game called rock, paper, scissors. And the player will play against the computer. The computer will randomly select one of the choices. The player will select a choice, and the computer will use an algorithm to actually use a business rule or a rule to determine who the winner is, and it will keep score, and it'll use various processing techniques. So let's go ahead and get started. I'm going to create a new project. It's going to be C++ Windows console application, and here it is, console app. Click next. Make sure we're in the right place. We are not. I want to be in projects video, and I'm just going to call this rock, paper, scissors. Very simple. All right. Create that, and here we are. We're back in a simple one. I'm going to go ahead and get rid of this this set of comment instructions here. All right, so what do we want to do? Well, let's get rid of the hello world as well. What do we want to do? Well, let's start by writing down some simple requirements. We want to display a prompt to the user. We want to read a line of input from the user. Then we need to start doing stuff. We got the line from the user. That's going to be their choice of rock, paper, or scissors. And we need to process that in some way. So we're going to have to process the user input into rock, paper, scissors, or quit, or help. Yeah, help. That should be good. So those are the choices that they can put in, and we'll figure out exactly how they can put those in. Then we need to have the computer randomly select a rock, paper, or scissors. Then we want to compare and determine winner or a draw. So if we both selected the same, select same, it is a draw. The next thing that we want to do is accumulate a score for the computer and the user in some way. And we'll figure out how we're going to do that. And then we want to display the results of the round and go back to so we can refer to these in some way. We'll just number them. And 8 will be go back to 1 or quit, depending on what the user selected. If the user selected quit or help, then we may not do this stuff in between. So actually here, when we do process, we can come in here and we'll say 3.1 if quit exit game, and we'll say 3.2 if help display help text and go to step 1. So that's our requirements. All right, well, let's start constructing it. So the first thing we want to do is think about, and by the way, I'm going to do this all just with functions. We're not going to get involved in classes just yet. We're going to do this with functions, and then later we're going to start seeing how we could arrange some of these things in classes in order to better manage the state of the game. What are the things that we need? Well, the user entry can be rock, paper, scissors, quit, or help. That's a bit of data that we need to deal with. We got to keep track of a score, and the score for the computer and for the user. So we'll probably need a data structure for that. And what I'm also seeing in here is that we're going to be doing some sort of evaluation, and we need to probably return some results from that evaluation that are a little more complicated than just an ordinary result. So let's start talking about what a struct is first. Well, no, let's begin with an enumeration. We could do this. We could do enum, and we could do something like rock, paper, scissors, quit, or help as kind of the recognition tokens for our system. So we're going to have to take whatever they type in and kind of turn it into these numerical tokens that are here: rock, paper, scissors, quit, or help. All right. So we've got that. An enumeration, the only problem with this type of enumeration is that these just basically are numbers. This is 0, this is 1, this is 2, this is 3, this is 4. And we're not restricted in any way. We can use these any way we want. We use them as numbers. We can pass them around and do things. In modern C++, there's a better way of doing this. And that better way of doing it is with what's called an enum class. And we're going to call this tokens. And the difference is, let's just go back to this enumeration. I'm going to take that out. The difference is I can do something like, if I do standard : cout rock. And if we run this, it just prints out 0, because that's what rock means in this case. And you notice I didn't have to put any kind of scoping on this. I didn't have to tell it where this rock came from, and this enum isn't really a type. These are just fancy values, fancy names for specific values within this range. And that's nice and that's useful. But the other problem with it is if I happen to have an enum, say, called, or an enum that I wanted to create, and by the way, there's, if we go like tokens, : there they are. So we can get those, and we can tell it, we can tell a function to use tokens, but really we can still use rock. If we run this, it's still okay. I could go tokens : rock, In fact, I'll take that out, and we'll just do another one here. We'll go SCISORS, and we'll just do that. You'll see that it doesn't care. It did 0 and it did 2. It doesn't care if we use this name. It also doesn't care if we use that name for a function or whatever else. This is very loose. If, however, we stick the keyword class in here, this is now failing. Why are these failing? Oh, yeah, they're okay. But I can't just send it out. The standard out no longer knows what this is. This is now a type. It's now a much more sturdy type. We can't just call upon these globally. They are now restricted to within the tokens type because of this enum class structure. And cout no longer knows how to deal with tokens. Now, we could do some other fancy stuff with that, but there's no really no need for that because we don't want to just output the token anyway. So we're not going to do that, but we are going to use this enum class for our tokens. But we want to be able to do a couple of things with that. We want to be able to convert something in a textual nature, a character or a string, and in this case really just a character. All we really care about is R, P, S, Q, and H, and we can parse that out of whatever the user typed. And so we need a function to deal with this, and we'll deal with that in a little bit. So that's what an enumeration is. There's two different kinds. I like the enumeration class. Not all C++ compilers may support the enum class, but modern ones do, for instance, in Visual Studio. All right, let's talk about a structure. We certainly need a structure for our score. So we can do this a couple of different ways. If we go struct score, we can call it int user and int computer. All right. So we have a struct now. The only problem with this is in order to use this struct, we always have to say struct. This is just an odd thing about the way these work. Basically what it means is that right now the word score, the name score, is within the struct scope. So if we want to create one of these, we have to say struct score, the score, we'll call it. Okay, if we just say score, if we just do this, it's not going to like that. It shouldn't anyway. Oh, I guess it did. In some contexts, you might have to say struct. I think it may be in, maybe it's in a function. Void update score, we'll call it, and we'll say score ampersand score. Yeah. And then we can say score dot user plus plus. Then we can call update score the score. Let's see out from the score dot user. All right, let's see what this does. So we've got our struct. It's odd that I didn't have to say. So it did increment it. There is another a way of doing this, and we can do it with a type def, which eliminates some circumstances when you might have to say struct technically. And this might be a Microsoft thing, I'm not sure. That works just as well. This is the canonical way of stating that I'm using this structure. If I come up here and we could just maybe change the name of this to, well, we can just say type def and type score down here and put an underscore T by it. Score underscore T. This score underscore T. This is another way of doing it. This is a type definition of this struct score, and now we just use this score T. And this should work just as well. There may be some compilers that won't like the other way that I was doing that without specifying the struct. So anyway, we have our score. This isn't exactly what we want for an update, so I'm going to take this out, and we'll take these out for the moment. So we've got a way of keeping score now. We know what our tokens are. We need to go up here to the beginning. We need to display a prompt to the user. So let's create a function. This function will be void, and we'll just call it prompt. And now we're going to bring in another include up here, and I'm going to do a include string and standard string prompt. That's what we want to display. And what we'll do is we'll just output the prompt, but there's a little trick that we have to do here. Standard cout prompt. We're just going to display it. We're not going to do the endl thing, but now in some terminals and some situations it may not display without a return on the end to flush the stream. So what we can do is go standard cout dot flush, and that will definitely push it out. So if we just come here and call prompt, and what do we want our prompt to be? Well, we kind of specified it here. Rock, paper, scissors, quit, or help. We can just put the instructions in there, but you know, we could let them know that they can also just type an R. They don't have to type the whole word. We don't need the or in there. And then we'll put one of these things on the end, and we'll see how that looks. There's our prompt. So now it put the prompt up, and then the program ended. So we could excuse me. All right, so we've got the ability to put out a prompt, and we can specify what that prompt is. And in different modes, you know, when you go into help mode or something, maybe there will be a different prompt asking you different things about the program. This is a pretty simple program, so this is probably all the help you actually need right here. It just tells you what to type, any of those 5 letters. All right. So here's our thing. We need to read a line of input from the user. All right. Well, there's a number of ways we can do this. We're going to want to return a string, first of all. And so we'll call this read user input. The easiest way in our world here is to get this is to use Getline, because it'll get an entire line of text to the end of line. And the way we would use that is we'll first set up a variable here of type string, and we'll just call it result, and then we'll call standard Getline. Did I say read line? I meant Getline. And what we're going to pass it is standard std : cin. That's our standard input stream from, and we'll pass it that string result. So what it's going to do is Getline will go out to standard in and read the entire line of text you type. When you hit return, it'll store it in result, and what we can then do is just return result. So there's how we read a line of text, and we get into the string. So we'll kind of test these out one at a time. So now we'll do read user input, but we need to store that, so we can say string input equals read user input, and just for the heck of it, we'll write it out to the screen. All right, let's run that. So I've got a prompt, and now we see it's waiting for user input. So I can say something like paper, and it printed paper. I could type anything I want in there, and we're not processing it or anything yet. So now what we want to do is, in case this is reading a whole line of text, so I might put spaces and tabs and go out here and say, you know, paper here. And if we were to just go look for the P right here at the beginning of this string that came in, we wouldn't find it. This would be an error. We want to be a little nicer than that and remove leading and possibly trailing white space, or in other words, trim the string. Well, there is not precisely a built-in function for that, but there are very simple ways of doing it, because strings have some very powerful facilities built into them. So let's work it out right now so that we can trim off all of this white space. So the first thing I'm going to do is create a constant string here in my global space. And I know this is technically a global variable, but we're gonna address that kind of thing when we get to doing the object-oriented stuff with classes. For now, I'm just going to create this constant string called WS, or white space, and it contains a space, it contains a slant n, new line, a carriage return, a tab. That covers all the possible white space that could occur. We could probably leave the slant f and the slant v off, but it doesn't matter. We'll leave them in there. All right. So we want to do first a left trim. We want to trim all the white space from the left side of our string. So let's create a function, and we'll call it left trim, and we'll send it a constant, And remember, when we say constant, it's not modifiable. We'll just call this input. Now we're going to have to check something. We're going to have to look for something. So the type that comes back from this is a size t, and we're going to call it start. And we're going to go to our input string, and we're going to call a function called find first not of white space. So what's this function doing? It's a function built into this string object, which is part of the standard library, that finds the first character in the string that's not in this string here that we created. It's not one of these white space characters, and it returns the index as a size t type of that first character. And so now we can return and I got a little bit of code in here. I'm going to do a quick lookup of one thing so that I can explain it precisely. There are some of these little artifact things. Okay. That I use all the time, but I don't necessarily remember off the top of my head the precise definition of what they are. This is going to be standard string npos. So this is npos is the maximum possible value of this size t. And so basically what this is saying is we're asking, is this start location at the very end of the possible length of this string? And if it is, we're going to return a double quote. If it's not, we're going to return input dot substring start. All right, so let me explain this. What we just created here is what's called it's an expression. It's a trinary expression. You've heard of possibly binary expressions, which is things like plus, minus, add, subtract, multiply, all that. They're binary expressions because they take two operands, one on either side of the operator. This is a trinary expression with two operators in it, a question mark and a colon. This part here is a Boolean expression that looks for true or false. The question mark says that if this part here is true, return this value. If this part here is false, return this value. So what we're saying here is if when we search this string for white space, basically all we found in the entire string was white space, we're going to return an empty string. Otherwise, if we didn't, we're going to return a substring that goes from 0 to that start. That goes from start to whatever the end of the string is. The substring here, this is the start location, the index into the string, so we're going past all the leading white space to the start, and that's what we're returning. Having a little trouble typing. Right, trim, constant, standard, string, ampersand, input. Okay. Same thing, except now we're going to do a right trim, and basically it's going to be almost identical to this. We're going to do a size t, and we'll call this end, and we're going to go input dot find last not of white space, and then we'll return almost the same thing, except it's not start, it's end, equals standard string end pause, which is that maximum length. So if it if where it searched, it tried to find the last that's not of the white space and it still hit the end of the string, then we're going to again return an empty string. But in this case, we're going to do our substring just a little bit different. We're going to go from index 0 to end +1. And the reason for that is this end part is not inclusive of the end. It would stop one before the actual end of our string. So we have to go end +1, and it'll stop one before that, which will be the actual end of our string. So we'll get all of the whites, all of the string on the right, or all of the string with the trailing white space at the end of the string removed. Now we can do a trim function, standard string, we'll just call it trim, again constant, standard string, ampersand input. And what we're going to do is return, we're going to call right trim on left trim on input. All right, let's make sure we understand what's happening here. When we call trim with a constant string reference, so what this is a reference to a string and it's a constant, so we can't modify anything in that string. We're going to first in here, this is going to call left trim input first, because it's got to fulfill this part here to pass it into right trim. So it's going to go up to left trim, it's going to remove any white space on the left and return a string. That string is also well, it's a string, so it can be cast into a constant string ampersand because that's safe. It'll pass that reference into right trim. Right trim will remove all of the white space to the right and will return a string that has no leading or trailing white space. Let's test that, and we'll just do it right here. We'll go trim, read user input, and then we'll output it here, but I'll do this just to be sure that we see. I'm going to put little quotes around our input so that we can see that it actually removed all the white space. So if I just type in something like test, obviously there's test. Let's run it again. I forgot it wasn't in a loop. Let's put some white space in, maybe some tabs, and they'll type in this is a test, and then some more white space and tabs, and hit enter, and you see the quotes are now around just this is a test. All that white space I typed in before and after has been removed by those two functions. So far so good. We've got our string that the user types cleaned up with at least some information removed from it. But really all we need is the very first character they type. Now that it's trimmed, all we need is this P, S, Q, or H, and they can type it in either uppercase or lowercase. So we'll take a look at that, and maybe well, for simplicity, we'll just do a simple function here. Here's our token. So we want to tokenize this input. You can only type one word, so we're not going to worry about splitting it down and tokenizing like a bunch of words yet. We may do that in a very future video here with some other types of games where you have to type in multi-word commands, but we've got single word commands. So we're going to make a very simple tokenizer here, and it's going to be a function that returns a token, and it's going to be we'll just call it tokenize, and we'll send in a constant string ampersand input. And why is it not liking token? I thought I called it token. Oh, tokens. Okay, tokens. And this has to have standard in front of it. All right. So here's our tokenized function. We're gonna pass this trimmed up input into here, and this is gonna be very, very simple. We're gonna get a character. We're gonna take our input character. We'll just call it ch equals input. 0. So we're just going to look at that very first character of the input. It's trimmed up, so whatever they typed, that first letter they typed needs to be one of these characters. And we can do this very simply. We can say if ch equals quote r quote or quote r quote, will return tokens : rock. I'm just going to copy this. We've got rock, paper, scissors, quit, or help. So it can be, and here a little Visual Studio trick. I can get rid of all of those at once, and we can go rock, paper, scissors, quit, or help. And this can be rock, paper, scissors, quit, or help. And this paper, scissors, and make sure I pick the right one here. This one quit, and this one will be help. So this will now tokenize the selection so that we can make decisions on that particular selection. Let me check the time here of my recording. Oh wow, we're at 39 minutes. It takes a while to code even something simple like this. So I think we're going to break here. We'll test out our tokenizer real quick here. We'll do a tokenize that trim input. I'm just stacking them together here, but this is no longer a string. This now needs to be not standard. It needs to be tokens, and we'll call it token, and we'll output our token. And we can't because it's that that type. But what we can do is this: static cast to int from token. And we'll leave on that note. This is a template function, and we're going to talk about template functions really soon because they're very, very useful. They're very simple to understand in their basic operation. There's a lot you can do with them, and there's a lot you can learn about them. They can be complex, but in their very basic uses, they are not difficult to understand at all. And they're very, very useful. So we will be using template functions like this one and creating some of our own in the future. So let's see what happens here. When we type in rock, we type in a lowercase r, it printed as 0. I'll run it again real quick, and if I type in a p, it also printed as 0. Interesting. That shouldn't have happened. Debug statement here. Return tokens, rock, paper, scissors, quit, help. Tokenize. This can't, that's weird. S. It's always coming back 0. That shouldn't happen. That should be able to cast that to an, oh, you know what? I think I know why. Let's try scissors now. Nope, it's still coming back 0 for scissors. And it should be 1. Scissors. Static cast to int from token. Why isn't it like this? Or, oh. Okay, we'll fix this real quick. ch equals equals. And now I'll show you this interesting facility of, okay, Visual Studio, multi-line select, ch equals equals. Little typo there. Now if we type S, we get 2. All right, it's tokenizing. So yeah, I just equals R or R. It needed to be or ch equals equals R, because this was always returning true because R is non-zero. It returns as a boolean if you want it to. R is a non-zero, so it would return true, and it was always returning rock. So a little mistake there. It's easy to do. So, all right, we are sitting right now at about 43 minutes into this video, so I've got to cut it short here, but I will continue on right where we left here in the next video. So thanks for watching. I hope you enjoyed it. If you liked the video, hit that like button. If you really liked it, hit the subscribe button. And if you want to get notifications when I upload videos, hit that notify button. Thanks, and I'll see you in the next video.